Okay, let's talk about the range sum of BST. So you're given the root node of a BST and a 2 integer low and high. So you have to return the sum of the value of all nodes with a value in the range. And it has to be inclusive range from low to high. So in this question, I'm going to use preferred search. So basically, I have to traverse every single node, and then if the value is actually in the range, I will just append. So I'm using the queue, and queue, I'm going to say queue equal to new linked list, and then I will have to just say if root equal to null, I will just basically, for the base case, I will just return 0. And then else I'm going to know, okay, this tree is not empty, right? So I'm going to offer, which is add. I will add a root equal to the queue, and then I will have to traverse until the queue is empty, because for every single time I will have to check the children. If the children.left is not null, I will just keep adding to the queue until the queue is actually empty. So I will have a value for while queue is not empty, and I will have a current size just to making sure the order for the current level, and the current level is like 2, then you would only traverse 2 times, because when you want to iterate your for your size, if you're polling and if you're adding, this will actually mess up your order. And I will say q.size, and then I will traverse my size equal to less than size I plus plus. And then for every single time I need to poll, right? So I will have a null equal to q.poll, right? Now I also want to return value, and I'm gonna call int result equal to 0. And then I will say if the node.val is actually less than equal to high, and also node.val is actually greater equal to low, right? And you will just add in the value to the result, right? And this is pretty much it, right? So I also have to check my left. If my left is not null, I will just add in the null into my queue. So queue.offer node.left, right? So same idea for node.right, right? Node.right. So queue.offer node.right. So this is pretty much the solution, and I will just return results, right? And using the preferred search is more easier to follow the logic. And I made a typo. And submit again. And here we go. Alright, let's talk about time and space. So this is going to be space, all of n. The possible you have to add a node into the queue is actually all of n. And the time is going to be all of n, traverse every single node, be honest. Because if you see the node.left is not null, you have to add to the queue, right? If node.right is not null, you have to add into the queue. So it's actually all of n for time and space. And for the recursion, this could be easier. So I made a recursion video. So if you don't know, then you can go on my channel to just watch the recursion video. And this is a solution, and I will see you next time. Bye.